Well, good morning, everybody. This is a nice, intimate session. I could probably come around and shake everyone's hand, but my name's Neil Barnett. I'm a senior product manager. I work in the SLE PM team, and I'm responsible for mission critical. And I have my learned colleague Diego with me.
So I'm Diego Keshi, so I'm engineering manager for high availability and mission critical applications. So very fancy, right? But more specifically for the products called HA extension and SLES for SAP. So thank you for attending our session today.
So we're going to talk about mission critical. From the number of people in the room, I can see people don't think this is to be the sexiest thing because it's not next gen. But I hope we'll show today that we're doing some great work, and I think you'll agree that people are missing out. So I just want to just very quickly level set on what we see as mission critical and why even today it's still important. And main reason, it costs money, serious money, breach of SLAs, lost opportunities with customers. And we've actually run some studies, Forrester was with one of them, and that they've shown that 31% of downtime is caused by some form of hardware failure. So not necessarily just servers, but actually infrastructure. But the surprising fact was over 55% of the customers in the survey were in a current state of needing to upgrade their infrastructure. So I would say that 31% is quite a conservative number. Second piece that I pulled out, which I thought was quite interesting, was the sheer volume of the applications that are deemed to be mission or business critical. And if you add that up quickly, even with my mind, I can see that to be quite a large percent of 72% are deemed to be either mission or business critical. So it's not a small landscape to manage. So what are we thinking causes downtime? My favorite is indeed climate change. So yeah, hardware and software failures, human errors, I think we'll all agree that they turn up. Diego, you have a great point yesterday when we were talking about this, that the human error is often masked by a very good manager, but it's still a decent number. So same survey, operational failures are our biggest culprit and where we can derive most of the value in our change. But I do love our natural disasters, not literally, I mean, as a talking point. You can see that they're not insignificant. These are interesting things to actually solve, interesting problems. And our human errors, even when masked by our great managers, still stack up at around 13% of human-caused events. So it's a challenge we're still facing today. So where do we start to solve the problem? I split this into three areas. We need to ensure that we're preparing for the inevitable failure of hardware. We also have to assume that our software, as much as we love it, is waiting for its chance to bite us in the something. I'm English, we don't swear. And finally, is removing the opportunity for our human errors. As best we try, these things do creep in. We're busy people. So what's SUSE doing to solve these problems? Okay, let's talk about preparing for hardware failures. So why don't we go ahead and just use these global resources? If hurricanes are a problem for us, let's move our workloads around. Let's do this automatically. And this is where SLE HA as an extension comes in. I won't read all of this, it'll take us forever. But the important thing to note here is from 15 onwards, that was last July, the Geo extension, which was an addition to HA, is now merged in, which means your HA is now Geo enabled. What do we do? Well, we pride ourselves that it's easy to use, but actually one of the things that Diego and Christopher and I talk about often is we call it a Lego kit. It's very granular, you can do what you want with it, which means it can be complex, so we do what we can to minimize this world while still giving you all the tools you need. Platform agnostic with all things to do with SLE, and we have self-healing and self-repair policies, and we also have a whole features, as I mentioned already, you've got geo-clustering, you can fail over both manually and automatic. I think Diego still today, manual is the favoured if you're moving across geos, but that's a separate conversation. Mission critical use cases when you're using SLE HA. So we have active-active, which we're looking at using for database, file servers, and so on. Active-passive. So again, this is where you're moving across geos as an example, and you might not want to move your SAP application between these two regions because you've identified in your super monitoring that's will be a short outage. We do use SLE HA in many SLE products. So SLES for SAP users will know that HA is a core deliverable and it's part of the reference architecture as used by SAP, and they use that internally themselves for their cloud platform. We also use it with our cloud platform to deliver highly available control plane. Simple example of all this I'm talking about is 3 web servers, and then God decides it's time for a natural disaster, and automatically we're moving our resources around to actually continue service for our users. So next, software we love, the software that hates us. How can we deal with that? Patching software. So the main issues, and I'm sure we're all still carrying battle scars of the last year with respect to our issues with our chip providers. But actually what we want to know is, why can't we just go ahead and patch our winning applications? Why, since we went to the moon in '69, can we still live in a world where life is so painful? And this is where live patching comes in. And in the room we have Libor, who is instrumental in the delivery of live patching, and he's here to make sure that I'm honest with what I tell you today. So live patching is a solution that will keep your services running, whether or not you're talking about planned or unplanned maintenance and you are reacting to vulnerabilities that maybe are actually outside of your sphere of control. External organizations or external teams are driving these needs for you to keep your systems up to date. And with live patching, you can maintain your security position without bringing your applications down. So this is what it used to look like, all the vulnerabilities throughout the year, a nice requirement to reboot, finding a maintenance window and going ahead and doing that. And if 72% of your applications are business or mission critical, this is going to be a nice outage. So let's just go ahead and lose the mouse. So we just live patch. What this means is that we are delivering to you fixes for these vulnerabilities, and you can live patch them without having to reboot your systems, which means no disruption to your applications. So the key highlights for this, it's available from SLE 12 onwards only, and we are supporting x86 and Power from Service Pack 3. We provide kernel-only bugs today, and this is for vulnerabilities, but we also do provide fixes for known integrity or system stability issues. There is no performance impact or interruption of applications. There are other solutions on the market, and you have to engage with the vendor, talk about your workloads to see if the live patching is actually appropriate. And with SUSE, it's not the case. It doesn't matter what your workload is, what your infrastructure is, live patching will work and it won't interrupt. Think of the use case of HANA. A 40 millisecond delay will be catastrophic. With live patching from SUSE, you don't get that. You deploy this with your existing management frameworks, and it's patches for all maintained kernels. Libor, did I make any promises there that we can't stand by? No promises that we can't stand by there. No, great. Thumbs up from Libor. An example of this, so this is quite a nice use case of a partner of ours, and they're using both SUSE Manager and live patching. And they've estimated that they're saving quite a lot of time. I think it's 2 days per calendar month in administration time alone. That's not even discussing what this means for the applications in terms of the business satisfaction. Live patching in user space. So as I mentioned, it's only been kernel so far, and we are working to deliver something in the user space, and this was about 18 months ago. There was the first pass at this, and the team decided this wasn't good enough because we had a real value with the way live patching works. So they went back to the drawing board, and at SUSE Labs conference last October, they demonstrated libpulp, and this is actually going to allow us to deliver the same service for user land as we do for the kernel today. This means no disruption, same patch threshold, same management frameworks and so on. And we look forward to people, I'm going to be here for the next 15, 20 minutes after the session. If this is interesting to you, we're looking for people to work with us on testing this. This is the next big thing for us in live patching. And the third area is our mistakes. I do like this one. So we all know this world. I actually did come from an infrastructure background for about 10 years, and I know this. This is my, 6:30 in the morning Saturday world. So what can we do about this? Well, as part of every SLE, subscription, you're going to get system rollback, because this is going to fix the errors between the keyboard and chair, all those other little nasty gremlins that turn up and say, good morning, this isn't going to work. And what we're talking about here is actually being able to roll back to a last known good state. So think about this as configuration changes that go wrong, we're not using automation, or an upgrade that's gone awry in some way. And as I mentioned here, it's even supporting the kernel if that's part of that day's task. So I think those in the room that have seen this kind of conversation before, what we've built here is a story around RAS. Reliability, availability, and serviceability. And you can see here, as we looked at, high availability, live patching, and system rollback are the three key pillars to deliver this. So we're talking about systems and applications that survive any sort of hardware infrastructure failure, systems that don't need constant reboots or fine maintenance windows to perform tasks that might be given to you from outside of your team. Because it's SLE based, this is any choice of your hardware vendor and or architecture. And finally, you can use this with all your existing management frameworks, which I'm sure all of you are using SUSE Manager to do this. I trust. So, are we missing something here? What about modernization? Surely the switch between the mode 1 and mode 2 world is supposed to solve these problems. And that's the question, are we actually there yet? Can we go to mode 2 tomorrow when we're talking about over 72% of applications that we deem to be business or mission critical? Okay, first and foremost, don't touch my applications, please. That really is a blocker to trying to get smart. I think the chat this morning, Diego, the Forrester guy, was really setting us up for this conversation. Application vendors, they need to be ready. They're not always ready. We might be running some really old legacy applications. They're going to give us a headache. So we can't necessarily modernize because of that. What about our hardware landscape? We might be on a 3 or a 5 year life cycle. We might be deep into our project running on System Z. It's not easy to do. How do we make use of this? And our internal processes. We all want to be agile and follow the DevOps model, but it's not easy to keep the lights on and it's taking all of our time as it is. And what are we missing out on? Well, it's going to be harder to leverage public clouds. Our automation's taking a hit. We all live in our day 1, day 2 modes, our deployment versus management. We're busy. This means that this unicorn of constant improvement and development takes a real back seat. Because, again, to keep those fires burning, we're going to keep working at 6 in the morning when it's time to abort the mission. Which means we're spending all of our time being reactive and not proactive. So is there a solution? Okay, well, what can we take from the SDI world? Well, I would posit we can take the idea of running our applications on multiple systems, and that automation and centralization would be key. I think if you look at there, things like always up to date and fit one purpose aren't necessarily correct for our mission critical applications, especially if we're talking about those that are legacy or aged. I don't know about you, but I think always up to date when you talk about mission critical is quite frightening. We'd like to do it, but it's not always possible. So I think maybe we could call it mode 1.5. There's something in the middle between mode 1 and mode 2. What can we do? Well, we said it would be simple, but we didn't say easy. So let's go ahead and try and leverage the private and cloud infrastructures. Sorry. Let's take a step back and design resilient environments which are still classified to be mode 1. Let's automate, automate, and automate more. Let's remove, where possible, these need for reboots. What can they do in our normal BAU world if we could do patches without needing to reboot? And then finally, you're going to need to go ahead and supercharge your eyes. Make sure your monitoring and your management is as powerful as possibly can be. So this is what we're going to call mode 1.5. So what is SUSE doing? And somebody smarter than I is going to tell you.
Thank you, Neil. Okay, so let's, as Neil mentioned, let's split this into days. So day 1 would be the deployment. And when we think about mission critical applications, they have been critical and will continue to be. So this didn't change for the last, I don't know, 20 or more years. What has been changed? So you notice on the keynote that it needs to be faster. It needs to be even more reliable. Now it needs to be global. And then it needs to be on the cloud. It needs to be on premise. And then the management comes, it needs to be cheaper. And then faster again. So how SUSE, how we intend to enable our customers to do it. So the deployment remains the same. So we need to be fast and scalable and high available. But doesn't mean that we cannot do it in an easier way or using more modern technologies. So SUSE intends to deliver what we call Lego kits. So meaningful and powerful components that you can use to enable your own infrastructure. So number one, it needs to be adaptable for your needs. So you can take the advantage and get rid of all the boilerplate tasks and activities that you repeat every day and use our components for that. We know that you have much more systems to maintain and they don't live alone. So a solution is composed out of many applications, sometimes in many geolocations and many different data centers. So we want to make this in a way that this can be integrated for your existing deployment. So mission critical application does not move in a disruptive way. It moves in a progressive way. So you do something, you try, you deploy. You try it again, you deploy. So, and then you try it on the cloud, and then you deploy. So automation and what we call Lego kits is key to give you the opportunity to really try it, experiment, retry it, adjust, and repeat it again. So that it only goes to production when you are really secure that it will work and it will really solve the problem and not create new ones. And we know that the modern world brings you extremely more complex applications. So we want to help you to deliver those complex applications. So we are talking, previously we talked about single instance database. Now we are talking about clustered database. Now we are talking about clustered solutions. So clustered application servers with clustered database, with clustered file systems. So the complexity is growing. And we want to cover this to help you that this complexity doesn't make you less agile. And as I mentioned, the idea is also to enable you to reproduce this as many times as you want in a security fashion way. So when I mean that this needs to be secure, that it needs to give you security to use this in production, we intend to do this using modern configuration management tools. So one of the most famous one in the SUSE workspace is SALT. Why we should use this? Because configuration management tools will bring idempotence. So this will give you the security, for example, for the selected use case that we have, for example, SAP HANA cluster, SAP NetWeaver cluster, or your high available NFS share, that you can guarantee that these states will be preserved. So when you deploy, imagine that today my business demands that I have a single instance database or a single HANA database. And then it grows. Now I need a cluster. Using idempotence, you can guarantee that this database will remain there and working, but the system and your deployment will grow and without disturbing or disrupting your current production. It will enable you to migrate and adopt the infrastructure as a code. So the idea that you can control your data center, versioning it, creating your own adaptations, and still taking all the control of it will be possible using our own components. So you don't need to care to learn or to deep learn and understanding how to configure the SUSE blocks of the Lego kit. Then you can put your effort to build your own blocks that compose the entire solution. And then it can help you to modernize your processes. So in the agile world, we more and more focus to deliver things faster. Doesn't mean that we don't want to deliver this with quality. And then processes like continuous integration, continuous deployment, that until nowadays you will need to build by your own inside of your own infrastructure. Now you can be composed with the tools that we are developing and will deliver in the future. So more or less how it will look like. So let's split this in three major layers about the deployment. So for the infrastructure layer, you can reuse this as you wish. So I imagine that you probably already have your YAS files or you have your SUSE manager configurations. And for the ones that are already in the cloud, you have something to prepare the clouds, or Terraform, or your scripts with the command lines of the cloud provider. This can be reused. Or we have a project that we are maintaining around Terraform that maybe you can use as a bootstrapping kit for this. Then comes the provisioning, where we call the Lego kits. So we have building blocks that will deliver you exactly the level of configuration that we want to have. So starting from what we call SHAP tools. This is a Python library for low-level management of the application. And our initial use case is SAP HANA, for example, but imagine that you could have APIs for GRDB, NFS server, cluster management, that you can use to compose your own scripting, for example. On top of it comes the SALT execution modules that are, let's say, SALT modules that basically executes a command. If you want to use it or it fits your needs, you can use it. But then we also will provide states. So SALT states are components that will provide you idempotence. So when you call a state, it will bring your system to a specific expected state. So for example, I want my NFS server installed. And then if I run it again, if the NFS server is installed, it will not be installed again. It will be preserved, okay? And on top of it, we will orchestrate and compose for you the formulas of the most useful and the most critical use case that we see for the mission-critical applications that SUSE usually supports. So SAP HANA, for example, NFS server, GRBD clusters, and many others. We are open even to receive feedback from you of what kind of applications, what kind of critical and mission-critical applications we should cover and consider for our Lego kits. Okay, and then it solves and it improves the day one. So now I can deploy faster, and now I can do it in the cloud, I can do it on premise, I can do it many times. And I can do in different geolocations. So we are considering that with the powerful of the cloud nowadays, I can very easily deploy this in Asia and South America from this desk, probably. But the complexity still remains. So, and this is critical for mission-critical applications. So the complexity grows, and then the monitoring capabilities also needs to grow and evolve, because more than react fast or deploy it fast, we want to prevent to need to do anything, right? So another topic is day two, how we manage that, how we monitor that. So what are our plans for the mission-critical environments? So we need a modern approach for the monitoring that's more capable. And then we are in the era of the data, so we should use the data in our favor. So what we want to achieve is a monitoring solution capable to correlate data. That correlates, for example, the data that we can extract from the machine with the data that you can extract from your cluster environment, with the data that you can extract for your own application. And then you can combine, oh, my system is failing, or will probably fail because the CPU is high, my application endpoint is not answering with less than 5 seconds. So I know that this occurs usually because this kind of failure, okay? So for this, we want to use modern technologies. So more specifically, we are talking here about Prometheus. Prometheus is a very prominent monitoring solution. It's a time series database that can really store time series data in a really easy way. And it has a very powerful query language that allows you to create your own visualizations, for example, and then allows you to create really complex comparisons and queries on this. together with Grafana. Grafana is a visualization tool, so it's basically a dashboarding tool, extremely powerful, that we can combine. And Prometheus also has something called Alert Manager that allows you to create really powerful alerts and to throw it in the many different channels available. So we are talking about emails, SMS, pager, but also about WhatsApp, Slack, and many other channels that you have in your organization. This Prometheus also has a wide environment in terms of languages. So it already has libraries for the many different languages and for the many different technologies. So that means it's extremely easy to instrument existing applications to combine with the offerings that we will have. So in that sense, we'll really be able to compare your own applications, your internal applications, with the SUSE behaviors. And then you can create your own intelligence for your own specific use case. Of course, we are picking this, and we want to use this to make it flexible and easy to use. So our main priority is to improve the experience that we provide for our customers and our products. We don't want to create something that we will migrate from very long reads to new very long reads. We want really to deliver as much close as possible that you have on your environment, and then you only need to tweak small configurations and small customizations for your needs. Again, as any data center, as any company, it needs to be easy to integrate. So our main goal is that this can be composed with your existing solution, that you can integrate sometimes on your own dashboard, that it can have your own look and feel, so that you don't need to change your operation to adopt what SUSE has as dashboard, but that it can really powerfully enable your own tools internally. And maybe for your end user, it's just aggregated value without even knowing that something changed in the background, okay? And as I mentioned, active alerts and reporting. So I forgot to mention, but tomorrow I have a session. We already have some prototypes about those deployments, and our first use case is a SAP HANA cluster deployment. So tomorrow I have a session at 10 about this, and if the gods of internet helps, we'll have a live demo. So please be welcome to join us and learn a little bit more in details how we are developing this, okay? If you cannot join, we also have this on the SLAS HA booth in the technology showcase, so we can discuss more about this there as well. And we also, some spoiler for you guys. So this is how our current dashboard looks like. So this is experimental, and this is under development. But here is the main idea. So you have, for example, your cluster nodes, you have your running resources, then you can combine and see how the machine is behaving. So how is the CPU load, how is the memory load, and then maybe you can include your own dashboards and your own components here. And then you can have how my application is behaving. And then it will be extremely powerful because you have your own business requirements covered in a single dashboard, okay? Yeah, so we have also a prototype running on our booth, so feel free to come, and people even smarter than me will be there to explain that. Okay, and more important, we want to give you a really nice user experience, but we want to give you everywhere, okay? So everything that we are talking here will work for on-premise, but also on cloud. And then ideally, you will be empowered to deploy on-premise, and then the business change it, deploy on the cloud, and then maybe it's change it again, deploy it back on the premise, or do a copy for your development, for debugging something, or any kind of daily business. Having the infrastructure as a code should be much easier, and especially that we are focusing to give you the opportunity to do this really everywhere, okay?
Do those formulas cover stuff like installing HANA?
Yes, it does, yes. It covers installing HANA, it covers enable the system replication, it covers configuring the cluster. So it's really focused on the solution. So you don't need something that will install the cluster only, but you need something that will deliver a working solution. And then maybe your HANA needs some tweaks, and then you can configure this later, or maybe you can adjust the configuration files, but we are focused on the solutions. So the same for NFS server. You don't need something that creates the resources on the cluster. You need something that gives you NFS server in the end. Maybe the NFS server or the SAP HANA configuration that we are delivering right now is not 100% as you want to have on production, but we want to have something that is something like 8% or 9%. And then all the rest, you do your own customizations. Okay?
Can that be customized so it is 100% what we want? Can we customize the formula?
Yeah, this is the idea. So currently, this is a GitHub project. Then you could fork it and adjust this. Or the formulas itself accepts a lot of parameters already. So you could tweak a lot of things. And if there is something specific, I would like pretty much to receive your feedback because, yeah, you can be part of the transformation. That's the message. So more than everything that we are doing, I think what was mentioned today is about our, I like it as well, the customer obsession. So we are doing this to serve your own purposes, so to serve what you guys need to do. And for us, the best way to do it is receiving feedback. So I will not cover on details, but as the name says, for example, the first use case and the first Lego kit is covered on this HA SAP Terraform deployment. And from there, you can see the SAP HANA formula, the library that I mentioned, the Hawk API server, and the other things related to monitoring. So feel free to come to the HA booth. We can discuss more deeply this, but also feel free to visit the projects, read the documentation that we already have, deploy it, and reach us, open issues, do pull requests. We really want to do this in a meaningful way and in collaboration with our users and our customers, okay? I think, yeah, I will hand over to Neil. Thank you.
Diego. So I've just highlighted a few items here that are of interest to us that certainly support our mode 1.5 thinking. Let me just go over this side. So when Diego's talking about the Lego kits, and it is kind of in line with your question about, you know, is it going to be what I get out of the box 100%? Please think about a Lego kit. When you buy something for your children, it might be a plane, and what they want is a plane with bigger engines, and you can do that. And the idea would be that you would fork this, and then there'd be another kit for people to use, and that's Diego's approach, isn't it? That's open and collaborative. But there are things that we already identify that we need to do in the products and the offerings to allow us to do more and more Lego kits. So something we're delivering in SP1 and 15 was from our cloud partners that we needed to have a watchdog service that wasn't dependent on hardware because we want to do this in the cloud, and we're missing key components. So standardizing on SoftDog was a way to achieve that. We're also pushing status for the cluster back into SUSE Manager. We have a lot of customers using SUSE Manager, and although we're working on using the APIs to open up for the dashboards, let's get it into SUSE Manager tomorrow, because that's a big use case for us. And you can also see in July of next year, we're looking at more granularity in how we can create clusters, again, to support these very granular Lego kits, but they're still going to be kits. You'll still be taking a box, and it'll probably work for you. You might tailor it, and then it'll give you 100%. And what are we doing for live patching? Libor, just look away. So we have userland. So I've mentioned already, it's the next big thing for us. So there is a prototype. We want to work with people and start looking at how it's going to work in the real world. We're integrating that with other SUSE products. We currently have that working with SUSE Manager, and we know there are enhancements to actually allow you to choose when it's time to do a reboot. There might be other reasons why you need to reboot your server, and it's nothing to do with live patching, but you want to see the status of the server before you go ahead and make that change. Live patching is a new product, relatively new, so we're catching up in terms of our support for the architecture. So IBM Z, that's a big one. We're seeing lots of customers demanding that for us. And then carrying on and extending the user land is something our partners are really asking for, which is they want to be able to live patch their own applications and their own libraries to provide the same level of service, but right up the stack. So that's what we've got coming up. That takes us to 2021, for example. That's, yeah, Service Pack 5, sorry. So that's going to be the end of this year, where we're looking for things like System Z, Libor. So I think that's the roadmap. I didn't want to bore you with all the items, but questions? Okay, well, thank you for your time. Thank you for attending the first session. I hope you have a great SUSECON.